One of our questions is like, if you save the muscle, is that enough to save the joint, right? Like if we find a way to like truly optimize muscle health, is that enough? Or are there other things that are going on after ACL injury that just, the joint needs to be treated separately in addition to surgery in some way?
I mean, how has your lab sort of morphed into this, osteoarthritis field?
My area of research has always looked at like muscular related outcomes after things like ACL injury, with the idea that that's something that clinicians can readily intervene on. We're not orthopedic surgeons, but what we can do, we think, is like save the muscle, potentially to save the joint. So my line is more or less sort of ridden a wave where we continue to follow the data depending on like whatever observations we've made. So I was more neurally heavy in the beginning because that's where the expertise sort of lied when I was training. I switched to being to integrating more muscle sort of midway through my early career. And now it's, we have sort of this neural and muscle component, but we really need to be taking a look at the joint as well. So we've onboarded technologies like micro CT to quantify joint health. And what's been helpful is using animal models, because then we can take sort of a direct examination of, what is the effect of this injury on joint health? How do different types of exercises either exacerbate that process or maybe make it a little bit better? So we've just kind of followed the data. And when, new systems needed to be onboarded, we've done that. And we've been really successful with different types of collaboration and people holding our hand basically through the process for the first time. So that's been really beneficial as well.
You've sort of developed this non-invasive ACL injury model in animals. And I think you supplied us with a picture of it, so we can put it up here and kind of walk us through how that sort of changed the way your research questions were developed and how that sort of moved you along. Because I know that was a pretty integral part of your young career right now.
Yeah. So this was developed when I was a postdoc with my mentor, Tim Butterfield. We, like a lot of things in science don't work out the first time you tried it, but like magically, like the first time we tried this with an animal, it worked, and it worked really well. So essentially what it is an overload of tibial compression that causes the tibia to basically slip forward on the femur and causes a non-invasive ACL rupture. So the benefit of that over some of the traditional sort of basic science work is that like a lot of people have transected the ligament in the past, which is like a fancy way to say that someone's taken a scalpel and cut it out. And although that's a very controlled way to cause an ACL injury, it's unlike what happens in humans. Mm-hmm. And by opening up the joint, just by opening up the joint without even transecting the ACL, you create some confounding factors of inflammation and other types of injuries that don't exist in humans. So what developing this non-invasive model allows us to do is to say like, okay, this looks pretty similar to what happens now in humans. It mimics the human injury condition. Now let's ask some of the foundational questions, about like modifications in gait and how that's related to PTOA, or is this type of therapy beneficial? Right. Because it more closely resembles what we see in the clinic. So the translation of it is fairly high.
No, and I use that model as part of my dissertation, and it gave us a lot of good information about, the quadriceps muscle that we're hoping to get published soon. Fingers crossed.
Yeah.
Right. We're not quite there yet, but I think so, because really, it is almost directly like what happens in humans, right? We see the hemarthrosis, we get a bone bruise even. And so this model allows us to look, but I think what's also really interesting about it is it sort of the beauty of animals is that their other limb allows for sort of a control process. And I think, you're allowed to sort of let them recover. Whereas humans, there's a much different clinical process after you tear your ACL. And so it's been very interesting to watch this model sort of evolve. So where is the research go? Where have you been? Where are you going? Kind of what are you guys working on right now?
I would say like our research generally has two different types of aims. One being like we want to fully understand to the best of our ability, like what are the consequences traumatic joint injuries, and in this case, ACL injuries, with the thinking that like we're never going to get this treatment right if we don't understand the disease and the disease progression. The second thing that we do is we typically take like, okay, what's being done in the clinic to improve muscle or joint health, and like test it.
Yeah.
So like many of our studies are sort of doing deep dives in either direction, whether it's testing something in the standard of care or it's trying to more fully understand like why muscle gets so sick after ACL injury. And like, if we better understand that, maybe we can be a bit more efficacious with our treatments.
Right. Right. I think a lot of these, what we think about as, these foundational questions that you're like, oh, that has had to have been looked at already, but it really hasn't. We did sort of a similar situation where we showed that, ACL reconstruction was a larger insult in terms of inflammatory biomarkers and cartilage degradation biomarkers than just the injury was. And, everybody sort of had been, talking about that and sort of alluding to that in the literature, but it hadn't ever actually been looked at. And so I think you guys did something very similar where you took this important connection that people had already been alluding to, but put hard data behind it, which I think is so important.
Yeah, I think there's like a lot of very reasonable clinical observations that people make that just need to be sometimes like justified. Like, yep, it's been shown like directly with data that, yeah, that's substantiated. What clinicians are seeing is real, they're important, and yeah, you should continue to intervene, at that level. So, clinicians get it, they see it. And sometimes we just need to follow up and say, yeah, we support you. Like, this is indeed a thing.
Absolutely. And so in terms of what sort of comes of that is, I think I haven't been practicing in a few years now as an athletic trainer, but, we sort of tend to not allow people to really use that joint immediately after injury or load on that joint immediately after injury, which I think, when you're on crutches or in a brace, leads to an altered gait by the nature of the fact that you're not using the joint as much. So do you think that, it would be beneficial to gait train even earlier than we already are? What are the big takeaways from that work for you guys?
I think what we can say now is that like gait retraining is a worthwhile treatment solution. I think that there are a lot of questions still about when to load and reload and to what extent. So I think we need to be more precise about it now. But what I think we can say is that like, you should be incorporating a gait retraining program into recovery. For sure. I think a lot of clinicians already do this, and this just kind of helps to substantiate it. But like exactly how and how much and when, I think are questions that are still open.
Right. And what the long-term effects on post-traumatic OA, are going to be, 10 years down the road.
Right.
Injury.
Yeah. I mean, that's like maybe one of the benefits of like animal models is that like you can ask some of these questions, apply it in a clinically applicable translational way and do a check, right? Because the timeline is so sped up that at least you can have like some data to kind of hang on to while we wait for the clinical data to come through.
Absolutely. So now we're, looking at the foundational kind of questions about gait. And I know also, there are you still working on the muscle side of it? So how are you incorporating that as well?
Yeah. So our next stage in some of this type of research is to look at the responsiveness of like the muscular environment in terms of like muscle size and sort of the inhibition that's so commonly observed. Like, can muscle be responsive to different modes of exercise prescription? So we're interested in like what happens if you do more of a lengthening eccentric exercise rehabilitation regime. Does that reinstitute the muscle system in a different way and the neural system in a different way than the typical standard of care, which is like more concentrically biased?
Yeah. And I know eccentrics are close to your heart. You and I've had the privilege to be on one of those papers with you looking at some eccentric work. And, I think when we think about OA as a population, and I think the broader OA community might, when you think of OA as a lot of joint degradation, cartilage, but, I think what we're learning with post-traumatic osteoarthritis in particular is that it is so much also of these other tissue systems, right? So many of, so much of the damage that we're seeing to the joint is perpetuated by these alterations in important systems like the muscular one. And so these can't be ignored when looking at, the progression to, full-blown osteoarthritis in these patients.
Yeah, 100%. Like some of these systems get really sick, right? And to think that it's going to have like this silo effect and it's not going to have like crosstalk and impair other systems is like pretty narrow. So what we've tried to do is like continually like either collaborate or onboard different skill sets to like consider, how other systems may be responding when the joint or the muscle itself becomes so sick.
Thank you so much again, Lindsey, for chatting with us and telling us about your work. And we're excited to continue, to follow and see what other really important contributions you guys, the Lepley Lab, makes.
Yeah, no, thanks for the opportunity. It was really great to connect and talk with you a little bit about some of the stuff we have going on.